No, I'm just here.
Michael.
I'm cracking.
Nice to see you.
So I was the opposite. My
I'm used to
consultant
Yusuf,
was.
Michael.
Right.
You're in through there.
Yeah, yeah. So you can sit wherever you want.
So I'll move over to you now. Now for some reason it's getting better. Let me look at the.
Do the test on,
Yeah.
Hello.
Hello. Testing.
what are you studying, Bracken?
I'm working with a couple of startups in the 7th floor.
Okay, I've seen you. Who are you working with?
I'm staff and working with.
Okay,
Yeah.
great. What are you doing your postdoc in?
Biomedical engineering.
Okay.
I do medical optics.
Okay. Where'd you go undergrad?
Undergrad was Cornell, PhD was here. And then second postdoc.
Awesome, great.
Yeah.
Are you a Clevelander?
Not originally. I'm from Pittsburgh.
Okay.
I don't want to get to Zoom settings on a PC, like I'm trying to get to the main.
What do you mean?
Oh wait, you know what, I can do this. Never mind.
I'll log into.
Why does it look so grainy?
Who's moderating?
Cameron, or one of our students.
Okay.
So in our last couple minutes, here, I'm sure now why.
And Yusuf, you're.
I am working
Dr.
with Dr. Zanakis.
Okay, great, okay.
He was on my committee, and I just sent him an email this morning, actually.
You were in, you.
I was in BME, so he was my outside
Actually,
committee
you
member.
gave
Like,
us
well,
Should I use
Oh,
yours?
no, I
Or should
did, yeah.
you-
Yeah.
Should I use my computer as
One of the
the?
mechanics person.
Yeah. That was a couple of years ago
Are you
now.
showing, we're just talking, you're not showing any
I have
slides.
some video, yeah, I'm happy
Okay.
to show some slides.
Okay.
So why don't you
The
join
reason I
via
sent you the
Zoom?
email was because,
And then you
my
can
PhD advisor
basically
ran
join,
into,
what, mute yourself?
and-
Yeah,
You guys
don't
are
mute yourself,
having
just
interest
don't
in Verlon
disconnect from audio.
Yeah.
Do your
Do you know
videos have audio?
Verlon? No, Verlon.
Okay, cool.
Brillouin.
So.
All right, apparently it's something
Do
that
you have the link,
Dr.
or you want me
Hughes
to-
was
I got it.
getting interested in again, and
Mhm.
that's, we have one setting up in Big Box. So
One of your
that's
kids.
why I shot an email.
When spring break for
Next
sure.
week.
All right, guys.
Good, how are you?
Good. Who's Cameron?
That's me.
Okay, so you're gonna moderate the
You
session?
switch.
Okay, switch.
You guys are gonna do that. Here between your legs.
Oh, I don't need a movie now, you could.
Are you guys grad or undergrad? Undergrad.
Junior. Senior graduating for that.
Nice. What's next?
Apply for a master's.
Okay.
Here, which we kind of.
Okay.
I don't know what it is, but is it working? It's not working.
Oh, it's working. I just got it unpinned. I'm, here, you can, I have this pinned really quick. Hold on.
Yeah, a lot of
But
things.
I mean, I would send it to you.
Great.
Okay.
Who's that person with the photo on your, above your name?
That's me.
I sometimes like, I use these older pictures of myself. Well, cool, let's,
Should I,
Carla.
start the,
Yes, start
Stream,
open,
okay.
yeah, because it's new. Yeah.
Actually, can I be right back?
Yeah.
I'm going to the bathroom.
Okay. Not sure, okay, good. Why don't we just quickly do, while Katie's out, some of you guys know each other, but why don't we just do a quick round of intro so we can get to know each other?
My name is Cameron. I'm a TA for Katie, and I'm a junior mechanical engineering student
Okay. From where?
from Case.
Where
Or
is
Minneapolis.
it?
Minneapolis.
Yeah.
My name's Jared Poconos. I'm a statistics major and I'm graduating this summer,
Where are you from?
Massachusetts.
Which part?
Marblehead.
Okay.
Very cool. Mindy Veale, I'm with the Veale Institute. I work with faculty and alumni.
I'm Yusuf Dikici. I'm a PhD student in mechanical engineering department, 5th year. Hope to graduate like this summer.
Right.
Working with Dr. Ozanakis and also Katie on bio-inspired robotics project.
Where are you from originally?
Turkey.
Wow, it's like Turkey
Another-
Day.
Which part?
The most northern city of Turkey, the central northern Sinop.
I'm from Turkey
I know.
too, but I'm actually a pediatric rheumatologist at Metro Health Medical Center, faculty at Case.
I'm Carla Macklin. I'm an entrepreneur in residence here at Case, helping Katie.
I'm Brecken Blackburn. I'm a part-time postdoc at Case in the biomedical engineering department, and I work with 2 of the startups up on the 7th floor of Fox.
Great. I see our collaborator and colleague Al Green. I don't know, Al, if you want to unmute and introduce yourself.
Albert Green. I've been working with Katie and several others on our Entrepreneurial Fellows Program, Faculty Fellows Program.
So we have a couple of other folks joining via Zoom. Isira, I don't know if you wanted to unmute and introduce yourself.
Hello, I'm Mr. I'm a PhD student in mechanical engineering. So I'm working with Dr. Daltorio and also collaborated with biology department, working with Dr. Dix and Angela. So,
Thank you. And Jessica, I see you joining. If you're able to unmute yourself and introduce yourself.
Hi, I'm Jessica Robb. I'm a business operations manager at Grants Plus and was just interested in the topic.
Great to have you today. All right, we will get going. Are we ready to start streaming?
It's
Second.
processing.
It's processing. Second, Megan will let us know when we're ready to go. As we awkwardly sit here staring at each other.
Waiting,
Waiting.
you see the buffering in our
Sending
head.
data.
Okay.
All right, we're good. So welcome everybody. My name is Michael Goldberg. I'm our executive director for the Veale Institute for Entrepreneurship and a professor of entrepreneurship at Weatherhead. It's great to have everybody here today in person here at ThinkBox, those on Zoom, and we have folks joining on LinkedIn as well. It's a thrill to feature and hear more from our friend Professor Kathryn Daltorio. You know, when one of the fun things about this job at Case has been meeting new folks doing really cool things on campus. And Albert Green, who introduced himself earlier, who's been working with us for a couple of years, was a real advocate for making sure that faculty really outside of, I mean, Julia's here from our School of Medicine, and we do some amazing things on the medical side of work here, and a lot of our sponsored research, the bulk of it comes from folks working in the healthcare space, but we have additionally, we have some amazing faculty working in engineering, working in material sciences. So the Veale faculty sort of commercialization fellowship, which Al and Mindy have been working on, and we have a pilot group, has focused in on really dynamic faculty like Katie that are doing cool things, which you hear about today. So Katie's been with us this past year. We spent time out at the Consumer Electronics Show together, and Carla Macklin, who introduced herself earlier, has been working as a partner with Katie to help her think and how cool stuff she's doing in the lab might go out. And again, this is a chance for us to hear more from Katie and a bit of her journey kind of out of the lab and balancing all the busy things she's doing. All of our sessions are moderated by students, and Cameron, thank you for volunteering to kind of help guide the conversation today. There's a couple of slides that they have that they'll share, but then we want to open it up to questions. So whether you're here at ThinkBox, you're on Zoom, or you're on LinkedIn, we'll kind of signal to you and make sure we get those other voices in. So Cameron, with that, let me turn it over to you.
Thank you and good afternoon. My name is
So
Cameron.
can you
Yeah, I got it.
okay, great.
I'm currently studying mechanical engineering. I'm a teaching assistant for our featured guest here, Katie, and I'm excited to introduce her. She does research and is a professor here investigating biologically inspired robots, kind of with the intersection of biology and technology, and I'll give it up to her.
Yeah, so you already had some questions and the first ones were like, what is your research currently? So I thought some of the best way of sharing that is through a couple of short videos. So I put some together about kind of what we do as a lab. And if I talk too much.
Turn your camera just so your face, have your just as an extra view.
Well, she's got hers.
Oh, you have your on, are you
I
on?
do,
Okay, perfect. Okay, sorry, Cameron. Go
but
ahead.
we don't have that for the.
Oh, you're there. Okay,
Yeah,
you're good,
because-
you're good. Okay, sorry.
No, you got it. So there's several of us in biologically inspired robotics. We have, sorry, that's gonna come up, but we have biologist collaborators and Roger Quinn and Brian Taylor, who's new. All of us work in biologically inspired robotics. And so my question has kind of been, how do we learn from specifically invertebrates to explore new terrains? And that's how do animals live so small? And we think it's more than just smaller parts. We think it's their coordination that's part of the answer to this. We think that it's some of their mechanics, and we'll see we make robots that are these sizes and shapes. So we think some about earthworms, and again, I'm going to go through this kind of quickly, but if you look at an earthworm, they're really good at exploring places that are really difficult for like a trenchless system. Like if you imagine unburying something like, let's say you wanted to do some maintenance on this pipe, well, you have to maybe go around all these other infrastructure pieces that you maybe also don't want to break. And earthworms are really good at this. They're soft, no bones, and yet they're so good at digging, so good at exploring. So we've made a bunch of different earthworm robots, different scales and sizes. And this is the first picture, which was like this one time a TV show came to film for a bunch of our robots. And we did that here at ThinkBox. We do simulations of worm robots. We do models based on how you would imagine segments coordinating to go different places. A lot of these worm robots are kind of based on the same idea. There's different segments and the segments get long and thin at the same time they get short and fat, and then we can attach all kind of other stuff to the outside of the robot. And we can do fabric ones. We've tested some at NASA. Joseph is here, so I can show off this video that he made with 3D printed really small versions of these. He's got even more that he's working on now, so just a plug. And then we also have some crab robots, and this has been kind of the entrepreneurship focus. We have some funding for this with the idea that we can use Lake Erie as sort of the kiddie pool for testing sort of shallow surf zone robots, which is a really challenging area for exploration. And this summer, yes, we finally got this great video where we were able to throw a robot into the water at the beach and then have it climb up and out. And I just want to point out how difficult this is, because there's these waves that are hitting the robot. And so you want the robot to be nice and heavy when it's in the water. But then as it gets out on the sand, you don't want it to be heavy. You don't want it to sink in too much. So you have to balance the weight really closely. And then at the same time, like right at that transition point, there's also an incline, and then you suddenly lose your buoyancy, but you still have these waves hitting you. So we think that a key part of this is the way that the robot uses its dactyls, just like a crab does, to increase the effective weight by holding onto the ground. So anyway, we have a bunch of different videos of this on different substrates, doing some different things, climbing. What happens if the rocks, I mean, there's like this optimal size where we have to have the dimensions of it that is the same as crab's use. We've got, here we have a user demonstrating how she can move her fingers and the crab leg moves, because another challenge is if you have a lot of user freedom, how do you control them all? Are there wearable gloves that we can use to make this work? And then there's other applications that we haven't explored as much. We can dig, we can pick up unexploded ordnance, which I guess I don't happen to have any slides on that, which is kind of the entrepreneurial side. But there can be other components that to think about in terms of how we control these lots of different robots. You can imagine for worms, we can imagine for crabs, we can be thinking through for flies, which is another funded project that we have. So that's just kind of a fast overview of what's going on in the lab. And of course, it's all possible because we have so many different students involved. And this is them winning a competition with a giant check in China. And, you know, so here's some of the crab team, but this isn't even everybody that has worked in the lab. This was a smaller group because it was COVID, it just happens to be my last lab picture. But so that's sort of a quick rundown of what we're doing in terms of research.
Wonderful. And so I have a few questions here. How do you determine which problems are worth investigating when your time is so valuable?
Yeah, well, I think that there are a lot of good problems, and this is where academia gets to be fun in the research space. We get to choose what's important to us. A lot of other engineers work for a company and the company chooses. So what we look at is we look at grand challenges that are sometimes I'm inspired by the National Academy of Engineering. They have 10 engineering grand challenges, and one of them is infrastructure maintenance, and one of them is water access, one of them is new tools for science. So I think that's exciting. And then I also think that government entities, like in this particular case, SERDP, which is the environmental branch or environmental group that does DoD research, they set out statements of need. And one of their statements of need was finding and accessing unexploded ordnance in shallow water. So they put that problem out there, and I'm like, ooh, that could be a fun problem to solve. So then we're always looking, right? Some of the best research ideas come from really like cross-disciplinary conversations that people have. But I feel like it's a gift when you find a good problem. and even though the title of the talk is like, oh, how I do this, how I'm trying to contribute to like real problems, even though I feel like, oh, my time is valuable. There isn't always like one single way of doing it.
Cool. And what are some insights you've gained from being a Veale faculty fellow?
Oh, well, I feel like it's been exciting to think through like what makes an idea a good business idea rather than just, do you want me to share this? Yeah. Okay. What makes a good business idea rather than like what is a fun research project? Because there's a lot of overlap, but there's like a lot that doesn't overlap. So I think it's been helpful to think through like what kind of partners you need. Like, you know, do you need a business person? And usually I think if you're a faculty member, you don't want to be, they keep saying you don't want the faculty member to be leading the company. We don't have the right kind of time, and we also don't have the same priorities. So I think that's been really good. And I think it's also the funding mechanisms are different. There's more risk, which is interesting, but it also means you get to try a bunch of different new things.
Cool. I'd like to open up to the audience if you guys have any questions.
And I could show a couple other things kind of based on our conversation too, but yeah.
Oh, I have a quick question.
Go for it,
So
please.
I was recently watching, of course, a YouTube video, and I don't know if you've heard of the channel Veritasium.
Yeah.
But I think they had like a kind of like video where they were talking about like the worm kind of robot and how like it can be used for like rescuing people from like underground collapses or stuff like that. And so you also mentioned research that had to do with water access. And there was recently, I think within the past week, it was reported that there was a nuclear power plant with contaminated water in Minnesota. So I was wondering how you think using things like worms design like could be implemented in a situation where it's important to like take measurements about these chemicals that are leaking.
Yeah, so I don't know all the details of the Minnesota thing. That's interesting. I should look that up. But a lot of times these piping systems for water are very old, right? Like a city is established, they want everyone in the city to have water, and so they make it. But they don't necessarily have an excellent map of what all is in that water system. And the things that we now find are important, like whether the pipes are lead or not, like they might not have written on the map when they made it. So they don't know what is there. And so even just that inspection of like, what does this map look like? Where is the water actually flowing? Where is there lead? Where is there not lead? Where, you know, like, how does that go? They have models and they have maps, but they're not always as accurate as one would like. So you can imagine worm robots being part of like kind of validating those types of maps. and putting eyes where right now it's hard to see.
Thank you.
And Al has a question too.
Yeah, hi, Katie. Can you speak a little bit to the role that your students play in your potential entrepreneurial pursuits?
Yeah, so I think every student interest is different, right? But I think that we often have students who want to build new things. And so we want to be connecting those students who want to build things with a challenge that is then going to be relevant for commercialization. And I'm just at the beginning of this, like, feel a little bit like, you know, not the best speaker on all of these entrepreneurship topics. But I think that like some students then are thinking like, okay, they want to do research because they're going to get a PhD. And some students are thinking like, oh, the research is part of like their plan to go into industry. And so if they're thinking industry, then some of them are starting to think like, oh, do I want to be involved in a startup? Do I want to be involved in these various things? But yeah, so the students are going to end up doing a lot of the building of the robots, a lot of the designing, and also like they'll have ideas too. Like they'll be like, oh, I think we could make this even better if we do this, or I think, you know, we could do this way. And they're looking for entrepreneurial connections to like, what do we need a robot to do? I want to build those kind of robots. I think is usually a lot of students have that kind of attitude. They're like, what can we build? What can we make?
Thank you.
Yeah, I have another question. How would commercializing your research, how do you think that could have an impact on how you manage your time?
Yeah, well, so I think that for us, as we're planning out like what that would look like in the case of the crabs, where we have this use case of there's unexploded ordnance that needs to be dealt with in different cases. The idea is and the way a lot of faculty end up doing this is they help a company get started, and then that company has a life of its own, and they advise and they help that company like as they're getting grants. But the company becomes self-sustaining. So then like the people who work for the company are paid by the company, and then the company like has its own progress and its own life. And the way it works at CASE is that any faculty member can spend as much as 20% of their time on external pursuits that are tangentially related to their research work. So some faculty will be like, okay, this is my one day of work, 1 day a week to like work for a company rather than work at CASE.
Cool. Yusira, you have a question?
So how do we know exactly at which point we can commercialize our research into some kind of like commercializing product or something?
Yeah, and I think that is a good question and one I'm learning about. I think the answer is about when we want to change the funding mechanism from government grants, which we can currently get, to other types of investments. And I think that a lot of the research, we're able to go pretty far with government grants, and probably we should exhaust some of those government grants before we go to like other types of commercialization. But there are specifically commercialization government grants. But so I think like when you can't get, and this is my new answer, I don't know if everyone agrees with me, but I think when you can't get any more funding on an idea, and then it's time to commercialize, because you want the idea to continue to have impact. You don't want to have like build this cool thing, the grant ends. Now you're like, well, this was neat, but what happened? Then that would be a little sad, right? Like, Isira, you're one of my students. So like, you know, when you have done you've completed your PhD and you've published your work, right? Like I want that work to connect to a larger problem. And that I think that can be where commercialization can happen. Yeah.
So in terms of career advancement and strategy, how do you feel that work towards commercialization is perceived in decisions like coming up for tenure, for instance? Do you feel like you get academic credit in a sense for actually putting something out into the world? Or do you feel like it's a little bit of a sink on your time when you also need to be doing these tenure related activities?
Yeah, so I think in your first couple years, starting a lab, I think right now commercialization is not as much valued as one would like. People are hoping to change that in academia. And I think like when you think about, okay, what point do you want to commercialize? Like at what point do you want to commercialize is different than at what point are you starting to think about commercialization? Because like you want to think about it early enough that when you're done, after your thing is done and works, then you have a story about where that connects, right? So I think it's good. So I think it's good to think about it early because you want to be planning in your research. This is something Umit told me, like even in our cohort, right? Like it's helpful to think early about what's going to happen to it. What is the key thing that you're going to, because what is the research that you need to do that you probably can't get commercial funding for? And so if you're doing that type of research though, then it is high impact. And then that is quite good for your career. Whereas if you're just like, you have a personal question and you want it answered, but no one else cares about the answer to that question, then it's harder to get tenure with that. Even if you're really happy with your answer, if other people don't think it's interesting, then it's hard for that to become a good tenure case. But I think there's really a lot of flexibility in an academic job, right? Like I can spend my time I have a lot of control over how I spend my time. And what's nice is that if things are going well, you do have time for a lot of other, that you can carve out some time to think about longer term projects. And that is part of your role as an academic. Like you can't just be blindly like putting things together like you might when you start out, right? Someone tells you what to do and you do it. No, you have to be the person who's making a good long-term plan. So yeah, I think.
Quick question. How does somebody, if somebody is interested in the topic that is ongoing, how does somebody contribute to someone's work? Maybe saying doing some good research and somebody wants to contribute to it.
Okay, what kind of somebody? Is this a student at the same institute or is this like a colleague?
Let's say colleague.
Okay, so colleagues is easy because like you're gonna work together, right? You might be like, hey, I have an idea for you, right? Or like in Yosef's case, right? Yosef is advised by two different professors in the same department, so two colleagues. And as I would be presenting, like during my interview, right? Like I would be presenting, oh, this is what we're doing with worm stuff, right? And Ozan, his other advisor, is like learning about this. And so then we can contribute ideas. We can be like, hey, I think this would work. And like, if someone sends me an email, like with a good idea in it, like, hey, that's a good conversation right there. That begins to be like, ooh, if someone has a good use case, if they're like, hey, we wish we had worm robots, but they were like 1/10 of the size. And I know exactly what I want to do with them. Or we wish we had this, or we have these materials, right? We have this new polymer, and when we hit it with electricity, it does this particular behavior. How do you have a use for that? And then we do. So then usually those kind of conversations with colleagues, they start as a fun conversation and then they lead to a funded proposal together is what you want, or sometimes a paper first. And then like those collaborations build over many years, hopefully, and you like end up with a friend and complementary technical skills.
Thank you.
Yeah, so Albert mentioned commercial market pull in the chat, and I was wondering how, like do you feel like you have the necessary market pull to commercialize your work?
So commercial market pull is an important indicator as to when to commercialize. This is what he says. That's true, but sometimes I think I don't know, my experience with the commercialization so far is that it's a lot easier to get government money on research grants if you still have research questions. We'll see, because the commercialization money, you're going to work a lot harder for that, for every dollar you get. And every dollar you get is an investment that you have to pay out on in a different sense. But yeah, so we're using Carla right now to figure out what kind of market pulls are there in the space of these types of robots.
Albert?
Yeah, staying on the student question side, looking back, Katie, on your graduate career and your graduate experience, would you, are there certain courses that or coursework that you might advise a student, an engineering student or a physics student or material science student to take if they sort of had some interest in or potential interest in that?
Yeah, are we talking about undergraduates or high schoolers?
I was thinking about graduate students, but it could be undergrads, it could be just students. Let's just say students.
All right, well, yeah, so I mean, any math and science classes are good. Any class that you're interested in is good. I do have like a list in my office of like my personal favorite classes that are offered here, graduate and undergraduate classes. And you know, there's a whole range from like actuators and drivetrains, which is Dr. Bachman's course, very practical, like this will teach you how to buy things to make your thing move, and how to think about like gear ratios and stuff like that, to like more conceptual classes, math classes, basic robotics classes. I teach a class on, you know, this more discussion based on robotics papers, kind of state of the art robotics now. So all of that is useful. And I think like you're trying to find in research, if you're a graduate student, you need to be thinking about where you're going to make your contribution. Where is it that is going to be like your cool thing that you can do? And so you want to take classes that feed into your interests, not classes that like shore up your weaknesses. I think that's a common misconception. You want to take classes that like will help you shine the best you can. So I know, and that could be different for everyone, right? Like some people are going to do some material science classes, some people are going to do a lot of AI classes, a lot of design classes, a whole range of classes are possible.
I have a quick question. So how do you work around intellectual property rights between commercialization versus university settings? You mentioned earlier when you can't get any more funding on an idea, then it's time to commercialize. What are the protocols?
But that's not the only time. Like that's the time to consider commercial.
So like the kind of follow-up is, what are the protocols when you start research at CASE and want to continue that research at a private entity unaffiliated with CASE? Is this addressed when you go through like IRB?
So the idea is, well, IRB is for human research, right?
Yeah.
So we are not normally doing testing directly on humans. So that's a nice advantage of working with invertebrates. If you want to study you can study as many worms as you want, and you don't have to do like anywhere near the paperwork. But this would be intellectual property. So the tech transfer office, when you have an idea, you as a graduate student or a employee of CASE, they will try to determine if it's a patentable idea. And if it is a patentable idea, then any spin-off company then licenses that patent. Through CASE. And I've heard, my understanding is CASE is a good partner, right? They want to be like a, you know, research powerhouse. So they want your idea to succeed for two reasons. One, they benefit from their name association with your success, but then also the invention success would then they get money back from that. So that's how that works with IP.
Okay.
But it is true that I think understanding the potential use case of your invention helps tech transfer make a good decision about whether it's time to patent or not, right? Because if you're like, oh, here's this cool device I made, it just looks awesome and does nothing, then they're like, great job, keep at it. But they won't patent it, right? Whereas if you're like, okay, I have something that the military could use and that you could put on every ship to retrieve unexploded ordnance, and okay, there's a market for this in other senses, then they're like, okay, well, we want to put the investment in to get a patent for that device.
I have a question, and it's sort of on the marketing side of sharing what you're doing. Megan Kuhar sitting to my left, and you guys worked on a really fun, creative video.
Yeah, show that. I can show that.
Which we actually probably should show, which was 30 seconds and had fun music in the background, the Styx version of you, Dr. Roboto. And I'm sort of curious, I mean, one of the hypotheses that I think we had as sort of a group of people working on supporting dynamic faculty like you and sort of sharing the work you're doing in different ways? Because I think the traditional way that you share the work that you're doing is through published papers and through conferences and, you know, short 30-second videos with an a cappella music. And I remember early on when we were talking about it, you were like, what crazy idea is this?
Well, I didn't
I'm
want
sort
to
of
be
curious.
Dr. Roboto. I was like, I don't know if I can be like the Dr. Roboto. There's other Dr. Roboto. Like I don't know. It seems like a whole thing.
But I'm sort of curious, like, I mean, having had that.
Like, is this video about me?
No, I think it was good. They were all good questions, right? Like, and I'm just sort of curious, like this, because we all consume things differently, and whether, I mean, those of us that are parents and who we both are, and we're seeing our kids consume differently. I'm sort of curious, being a researcher and sitting on the other side of sort of a fun marketing video. I'm just curious, like, what, because I know you had, you know, as you shared some feelings around it, I'm sort of curious what that experience was like, and does that, should we be thinking differently as a university about ways that we sort of share things that are just, it's a totally different path than what you typically do.
Yeah, and I think like there's a lot that technology enables, like in terms of sharing your research, and it's kind of, it's not something that like I'm necessarily going to be good at, right? Like I don't have a lot of social media presence. I don't think about this very often. I like, you know, I like doing math problems. I don't like talking to a large group of people facelessly on the internet.
Yeah, right.
But you guys are
like today, right?
But yeah, so like I think there's a lot that's like unclear, and there's a lot of ways it can go wrong too, right? Like scientists, and even if you talk to more experienced scientists, they'll tell you like, oh, I did this thing for a promotional video and then I felt like embarrassed afterward. But I don't feel that about the video that Megan made. Like it was fine. Yeah, so there's a lot of this. It certainly lends itself well to video, and we've been on video a bunch of different times. We've been part of like TV show crews have come several times, Discovery Channel, you know, various little, because it lends itself well to be like, oh, look, here's a video of the robot working. And it's actually a really nice thing about being in robotics is that you can quickly show a video and like, you see, oh, this is what we're doing. I think it's great. I think like more YouTube, more video content, ways of sharing video content are valuable. There's sometimes a conflict between like, as you're doing robotics research, sometimes your success of your robot is demonstrated in a video. We say if you don't have a video, it didn't happen. So like you actually, the video itself is part of a publication, which then has its own like rights and rules around it, right? So like if you could scoop yourself, like you could prevent your students from publishing a video if you sent the wrong video to like, you know, your university's marketing department and they publish that online, and then now someone goes to try to publish, okay, I made this work and this is how, and then it can't publish it because it's old news now. So some of that is complicated, but it was fun to work with you, Megan. You know, and like the video came out great, and it probably was good because it was about like the team rather than about like, the science.
I mean, and even like kind of seeing the response from other people talking to you and already know, like it's like an intro to what you do.
It's been a fast way to be like, hey, check out this video Megan made.
Yeah.
So if you even have it, do you want to show it?
I do. I just had a weird connection issue, but I think I'm back. So I was gonna ask kind of while I'm getting this ready, you mentioned that like as an academic, you kind of have freedom over your time.
Oh yeah.
So how do you prioritize that then?
And I
Like,
can
how do
show you,
decide?
I have some baby pictures I was gonna show of my family, so you guys can kind of see like what my life is like if you want. But like, maybe you want to show the video first.
Yeah, okay, let me get that. Hold on, I'm gonna share my Instagram screen and play it because we need like 60 more views before we hit 4,000.
Oh, yeah.
Whoa,
So I am
quick, those at home, click on it quickly.
Watch it several times.
Several.
Okay, here we go. That's you.
Could be this.
That's me.
Oh, it has to be on.
Maybe it's you, Katie.
I'm not joined to audio.
Let me like join it and then unjoin it.
Okay, sorry about that. Can you hear us,
Okay.
Alan?
I think we're
Okay,
good.
great, thank you. Sorry about that. Okay.
All right, I can also show, all right, so when we think about, so I thought I would share even in my life, like kind of my path a little bit. I started working at NASA. I worked on a robotics team and I got involved in the biologically inspired robotics lab. This is a lawnmower. And then I had my first daughter. And I was working on my PhD. And like not, yeah. And the robot was doing well. I was pregnant with my second child when I got my PhD. And now I have 4 kids. Fast forward. Anyway, so like I thought I would just share that like this is why to me my time, I mean everyone's time is valuable. I don't mean to say that way, but my time is valuable to them. And so when I think about how I'm going to spend my time, I do try to prioritize being home when they're home from school. And I've tried to balance like, you know, times in my life where I needed to be home and times when I could do some thinking and being able to do thinking while I'm at home. You can think while you're loading the dishwasher. You can write an excellent PhD thesis while holding a baby. As some of you know. Yeah. And I think that like one thing I would not have known going in is how much of that you have the freedom to do if you become good at certain aspects of your job. And so then, but you were talking about mentorship. There's a question about importance of faculty mentorship. So yeah, I definitely think that, for example, Umit Gurkin, who's in my department and knows more about commercialization and just got like this $3 million grant for his company Chemex that has to do with blood technology. Right? Like he is a huge inspiration, and it's kind of like it can be a question like you're going to invest all this time into any kind of commercialization or entrepreneurship work that you do. Why does it benefit you? Like it was unclear to me for a long time, like why you would even want to do this, because there's always a risk, and we're academics, so we've already decided that we're not going for the most high-paying jobs. So you've already like made that choice when you choose to be an academic, that you're not going to be maximizing your income. So like, why are you like, and there's so many different ways that you can serve in academia. You have students that you want to help. You have just a lot of different ways you can help your students succeed, and that's really rewarding, and you don't want to take time away from that. But then commercialization can help, so it can help students because you want their work to result in good things, and you want them to get in industry jobs often because they want industry jobs. But I think the key is impact. So if you think about what is commercializable, that is kind of like what is doable, what will be the real result of your work. And if it's never going to be commercializable, then it may never have an impact. And sometimes that's okay. Sometimes you know that you're contributing to science for science's sake. But if you can think through like, oh, I'm gonna like aim my research at things that I know might be more commercializable, then I think that increases the impact of your work. And you see that with Umit, right? Like you see how his work has been impactful and commercializable. Like, so he's doing well on multiple accounts because of that. And there's and it's been so fun to meet all these other faculty and to talk to all these other people that Al has been introducing us to, and we always ask like a million questions, like, why are you, what was behind this choice, or what was behind this?
I have a question.
Yeah.
What did you do or what did you experience that helped you shift from undergraduate engineering where things are prescribed, right? You're being given the problem you're told to solve. You're being told there's one right answer in a lot of cases, to being able to look at the world and say, I want to uncover important problems to solve. How do you make that shift? Was it a mentor? Was it just curiosity? You know, how do students pivot that way?
So I think for me, it was working at NASA.
Okay.
Right, so I work at NASA, and you see that like there are some people who get to work on harder problems, and there are some people who are kind of like always working at the same difficulty of problem. And I could see that I wanted to work on the harder problems. So that was like, okay, for me, that means I need graduate degrees. I want to be answering questions that we don't know if it's even possible to answer. And that's more exciting to me.
So that's sort of an element of, you know, if you can see it, you can be it, because you saw that,
Yes.
you could look differently.
Maybe that's an element of you can see it, you can be it, but it's also you can see how like and some engineers do this really well. They specialize in a certain area, and then they're going to do that one technique and perfect that one technique for their entire career. But I wanted to like think bigger about the problems, and I rather than do that type of specialization. And then the more we did that, and then in graduate school, you get the chance to mentor others, and you see how rewarding it is to work on part of a team, to be kind of pouring into other people's work, right? Like then their success is your success, and also it's fun because they bring so much into what you end up building, like a lot of energy and fun. So then it seems like, oh, well, maybe you would enjoy managing, maybe you would enjoy, but then you get away from the technical side too. So like, I like being able to do a lot of that.
And do you think that pivot then influences the culture in your lab? Do you encourage that, look for bigger problems?
I would like to encourage that. I don't know. I think my lab culture has been great because the students have been great. And they're just like excited to be solving different problems. They seem like they're happy with the success of their projects, right? And so then that shows others that like, oh, look, this can be done. And it's also like, sometimes your project won't succeed. Sometimes you'll try something and it won't work. And that just like not giving up attitude is something that they've been good at showing, and that, you know, and we don't want to be discouraging them for trying something and having it fail, right? That's actually a success. When you break something, you have tested to failure, and that's good.
Yep. Awesome.
Jessica brought up a great question about what strategies you use to prioritize which problems you're going to solve, and there's obviously so much to investigate.
Yeah, so you got to think about what can you do, like what are you the person to do, right? Maybe I think, you know, we should have a new biofuel for burning in power plants. I don't have the skills to develop that, right? But I do have the skills to think about maintenance of windmills, maybe how you stretch it, right? So you start with one thing that you're, at least in academia, like a new professor will have one skill that they learn from their PhD, and they'll start with that. And then they'll kind of like slowly expand over time, like letting their one thing that they know touch something else, and they kind of broaden out. So part of that is what can I do well? Part of that is what is needed, in my opinion. And I like that in academia, we get to decide a bit of that. Do I think we need like, you know, cushier armchairs? Or do I think that it is, you know, that we should be solving problems that can't quite be commercialized yet, but then that will be when we're done. And so I like that we get to choose those problems. What is fundable also matters. Like, so you have to kind of have a sense of what different program managers will fund. And then you also have, what is it you want to do? And what is exciting for you and your team? And I think, so that combination of things helps me decide what projects to attack.
Cool. All right. Last quick question, yeah.
Okay, so there was a recent talk about the use of ChatGPT in academia hosted by the Veale Institute, as well as other upcoming events that discuss the applications of ChatGPT. Later this afternoon, USite is holding an event called ChatGPT Panel Discussion, Considerations for Teaching and Learning. How do you see yourself incorporating ChatGPT in your classroom, research, and personal life? Maybe you could use it to try things you never considered before, like writing a book.
I could write a book because ChatGPT would write the whole thing for me. So I think ChatGPT is what I think is exciting for roboticists is that ChatGPT is kind of a window of like what AI can do, and it's what AI can do with words. But there's all sorts of data streams that are available to put into AI and things that could be done with that. And so when I think about what am I excited about AI, usually it's not chatting with others. Who even wants to do that? But it can be like thinking through, if our robot, for example, is collecting a lot of data, how can we process that data in a way that is explainable to others and useful? But right, ChatGPT could be helpful for students writing papers. Like we have to, as academics, publish what we learn, right? This is an important part of passing on what we know. But writing is challenging. It's challenging to write well. So maybe we could use ChatGPT to help like first draft some kind of boilerplate text and then refine it. I don't know, but that's like, who wants to read ChatGPT text? Maybe we'll use ChatGPT backwards to like extract a bunch of information. I don't know. So I think there's a lot of possibilities, and I'm not frightened of it in like a plagiarism sense, because I think there's a lot of plagiarism checkers. And if you're saying something that's already sort of out there, then maybe it's not, maybe you should find something different to say.
You mentioned like trying to figure out what programs will be funded versus like what's funded for your team. So I feel like that's like a great resource to kind of figure out like, okay, these are the strengths. Like you were saying, these are some of the things that might have like correlation between different industries, and like maybe like you don't have the full time to like explore that, but like you could kind of do that in 30 minutes and you don't have to go down the rabbit hole of reading 20 research papers. You know what I mean?
Yeah. But you get faster at reading these research papers.
Okay.
Right? I think that's a skill that's worth developing. And maybe ChatGPT would help, but like you get faster at skimming them, right? Whereas if you try to like read a research paper, like from the beginning to the end, like you're just gonna read every word, like it'll be a slog. You'll have to look up a bunch of stuff. And you won't get super far. Whereas if you are familiar with kind of the structure of a typical journal article, like you know where to look for the questions that you have. So like I look at a paper and I'm like, okay, my questions for this paper are, like what robot were they using maybe, or like what technique was this used? And so you know where to jump into the paper to find the answers to that question. And then if it's well written, then you want to read more of that paper, maybe, and then you pick out different parts of that depending on your interest. But we mostly aren't like, and I would be even less excited about like reading a ChatGPT churned up version of papers, because I don't know if I would trust it yet. But maybe it would be a good start, just like sometimes you start with Wikipedia and then you like, go in.
Cool. All right, we are unfortunately out of time. Cameron, thank you very much for moderating the session. Great questions from folks here, and of course from our friend Al Green and Jessica and others joining via Zoom. And Katie, thank you for sharing today's session and your experience with this, and just being such a great partner throughout the whole year on this pilot fellowship. And I think the work that you and Mindy and Al and Brian and Omid and Bill are doing together really sort of set the stage for hopefully more of the kind of work that we want to be doing to engage awesome faculty that are sort of, testing out ideas around entrepreneurship and commercialization.
Yeah. And I think it's been fascinating to learn from Veale all these different potential avenues. It's exciting to think through like, oh, there can be a lot of different paths
Mhm.
as an academic, which I think is really interesting. And I just, again, I want to appreciate all my students, just to point out that like, I think they're kind of beginning to be interested in tipping their toes into more entrepreneurship because of what we're learning as a team, right? I think for some of them, they're like, no, I don't want to do business. That's why I'm in graduate school. Right? But I think like there can be possibilities to do some of both.
Yeah.
And I think like for me, helping them navigate that and providing good advice to them is something I want to know, just so that I can be the best type of mentor I can be.
Well, cool. We have another event this week, tomorrow at 4 o'clock. Sarah Hines, who's a strategic innovation director at Humana, will be joining in person. That event will be at the health education campus, and that's in partnership with our friends from the School of Medicine's Entrepreneurship and Innovation Pathway at 4 p.m. And it'll also be on Zoom and LinkedIn. And then we have an in-person event on Friday. William Tavel, who's a double alum of the university, is, and this is focused as a workshop for our Morgan Thaler Pavey startup competition finalists, but open to anyone on running a SWOT analysis for your business or idea. So that will be right here at ThinkBox at noon on Friday. And check our website for other future events. So thank you everyone for joining today, and we'll see you all soon.